Hi, over the next few videos I'm going to be demonstrating how using the revolutionary 3D simulation software for industrial automation called FactoryI can assist you in developing ladder logic for the Siemens S7-1200 PLC. And to help us through the process, I'll be using FactoryI's conveyor box setup and programming it step by step, sorting out any coding issues as they arise. So stay tuned. Welcome back. So let's get straight to it by restarting FactoryI and see what we're trying to achieve before we then close the PLC program and start coding from scratch. Now, the entry conveyor starts emitting boxes of different heights completely randomly, and the height of each box is detected by the light array emitter, beam if you like. Then, depending on whether a box is large or small in height, determines whether they are transferred either left or right. As you can see from the simulation, the larger height boxes are being transferred right, and the smaller height boxes are transferred left. Now let's stop the system and close the ladder logic program and take a closer look at where the inputs and outputs are located on the conveyor system, and also their type. To make life a little easier, I've listed all the inputs and outputs in a document, because as you will see shortly, the text in FactoryI is really small and difficult to read. Right, let's scroll this document up to view just the inputs and outputs. We will come back to the internal bits shortly. Now the first three inputs are from the light array emitter. We'll just call it beam from now on. Let's zoom in and take a closer look. These are normally open sensors and therefore are set to false until a pallet or box is detected. The bottom beam detects a wooden pallet. The next beam detects a small box, and then the beam above it detects any box higher than a small height box, which is classed as a high box. So those are the three inputs that we detect, although you will see that we actually don't use the small box beam sensor. Instead, we use logic to assume that if it is not a high box, then it must be a small box, although you could write code to include a small height box sensor if you wanted. Anyway, that will all become clearer as we get into the ladder logic programming. The next input is also a normally open sensor that becomes true once a pallet has reached its limit on the small loading conveyor and is ready to be transferred either left or right. As I swing round the conveyors, you can see it a little clearer. Here we go, swinging round. Let's zoom back out and we can go back in and view the next four inputs on the list, namely at right entry, and as we zoom out a little more we can see the at right exit. And then on the other side we have similar sensors that detect at left entry and at left exit. These sensors are normally closed, and we will use them to detect pallets once they are completely off the small loading conveyor and also removed from the left and right conveyors. The next five inputs on the list, from input 1.0 to input 1.4, are all in the panel, and we will incorporate them in later videos. The last input, input 1.5, is generated by FactoryI to say when the system is running, and we will use it in the ladder logic. Now let's have a look at the outputs. The first output is the entry conveyor motor, which allows boxes to travel from the emitter towards the loader. The next output starts the small loader conveyor going forward, and the next one allows the conveyor to go in reverse, but we won't be using that output in our code. The next two outputs, Q0.3 and Q0.4, allow pallets to transfer either left or right off the loader. Once these outputs are engaged, the three yellow bases come up and their chains move the pallets either left or right depending on the height of the box. Then the respective outputs, Q0.5 conveyor left or Q0.6 conveyor right, will start ready to accept the pallets. The last outputs are for the green start light, the red stop light and the amber reset light, as well as the digital count, which we could use to keep count of the boxes going through the system. However, again, all these panel functions will be incorporated in later videos. Now let's scroll down this list and you will see some internal bits which will also be used in the ladder logic. The use of these will become clearer once we start coding. Suffice to say, we do make use of good programming principles in that only internal bits will be set and reset, never the actual output relays. Again, you will see this once we get coding. Okay, let's start up the TIA portal. Keep this list open and refer to it when we need it. Okay, I'm going to start up a blank program. The reason I've chosen this one is that the hardware is already configured and saved rather than going over old ground that we cover in other training videos. So the exact PLC is set up. So too is the input offset start address, because we can't actually use the factory I/O input addresses on the PLC as they don't exist. However, this is one of the benefits of using factory I/O, in that you don't need to have all the physical inputs on your PLC and can make do with a smaller PLC. Okay, let's select Open the Project View and select the PLC. Then we can check the hardware device configuration. That's the PLC we are using. Then select Program Blocks and OB1, which will be blank and ready for us to start inputting our ladder logic. Okay, let's move this list out of the way a little. Over there should be fine. Then rather than entering all the I/O details and tags in one by one as we code, it's a good idea to enter them all beforehand so we can bring them up as and when required. Also, if we use input 1.5, for example, without declaring it first, because the inputs are offset and physically don't exist on the PLC, errors tend to occur during compiling. So select the PLC tags and add a new tag table. It should save us some time when we come to coding by doing things this way. Did I select that? Let's try again. Oh, it looks like I've created two tag tables, so let's use the first tag table and enter the tags. We'll click in the name field and I'm going to enter I in front of all the input tags and O in front of all the output tags. So I underscore high sensor and click in the next field or press enter. Notice the first input comes up automatically, which is great. Type in the next tag, which is I underscore low sensor, and enter and continue for all the inputs. So I'll just do that now, and rather than bore you, I will fast forward a bit and return just as I've entered the last input. Okay, we're back. And I'm entering the last input, which is the factory I/O running input. And now I'm going to start putting in the outputs, and the first one is conveyor entry. So keeping with the convention, I'll start with O underscore and type in the tag conveyor entry. Now this time it's continued the input range automatically. So to change this, let's click in the address field and change it to Q0.0. Then click in the next tag field. Now type in O underscore load and enter. And notice the output address changes automatically, continuing on from where the previous output address left off. So guess what I'm going to do now? Rather than watch me entering all the addresses, I'm going to fast forward again to the last output tag. Okay, now it's time to enter the internal bit tags. I won't use a prefix this time, although you can if you want. So loading, and this time change the address to M0.0 and so on. So I think you get the idea. Let's fast forward again. Okay, so we've completed the tags. Now let's go back to start entering the ladder logic code by selecting main OB1. So let's just hide the I/O list for a while. Then I'm going to enter a name for the first network. We'll call it Startup. Then click on the Startup network, and from the menu select Insert Network to enter Network 2, and then do the same again to add a third network. Now let's name these networks loading and outputs respectively, and we should be ready to start adding PLC ladder logic. So let's go back to the first network. Now, as the internal bits will all be set in the PLC ladder logic, the first thing we should do to get things running is reset them all as a safety precaution as soon as FactoryI starts running. If you can remember from the tag I/O list, there is an input that turns to true once the system starts, and we can use this input to reset all internal bits at the point of startup only. So the way we do this is to select an RTRIG data block under Bit Logic Operations and place it in the first network. Its default name is RTRIG DB, and it will be numbered 1, as it's the first one used. Select OK, and on the CLK input, we need to enter the input FactoryI running, which we can select from the list. Then input 1.5 comes up together with the tag FactoryI running. Now, to ensure the internal bits are only initialized once when the ladder logic starts to run, we need to add a normally open contact to the ENO output of the block. Again, let's select the data block from the list for the normally open contact, then select Q, which ensures the path is only made on the rising edge of input 1.5. Now we can add all the internal bits as outputs to be reset. Select the line on the network and then select the first coil. Then select between the output coil and the RTRIG Q contact and select branch. Add another coil and select the line again, and so on until we've added all 5 coils. So I think you get the idea. Let's fast forward. Then I can add the address for each of them. So the first one is M0.0 and change the coil to a reset coil. There we go. and I can do the same for each of the other coils. First, I'll just change all the coil types to reset. Then I'll go back and add their addresses. Let's fast forward. Here's the last one for the high box. Great, that's done. Now we're going to scroll down to the outputs network, and we need to start the entry conveyor running, and then we'll see what happens. So let's bring down an output coil, and from the tag list select conveyor entry. Let's just compile the code to see if it's all good before we download it all to the PLC. It now tries to compile the code. Now it does give a warning, but that was to be expected at this stage, as when using FactoryIO, the inputs addressed in the ladder logic are not physical I/O, and so really don't exist, but we should be okay once it's all downloaded. So let's do that now. Select download to device, and let's fast forward. Up comes the load preview window, and we need to overwrite what is in the PLC now and reset it. So let's do that. Select delete all. Oops, because we are deleting the existing hardware setup, FactoryIO can no longer communicate with the PLC. So let's select OK on that at this stage and reconnect in a moment once the loading is complete. So let's select Finish and start the PLC module. And as you can see, there are now no errors and no warnings. So let's go into monitoring mode by selecting the glasses. We can now see the orange line and green lights indicating we are now monitoring. The output coil is on, but we aren't talking to FactoryIO at the moment, and we haven't reset all the internal bits, as input 1.5 isn't true because FactoryIO isn't running. So let's go to FactoryIO and connect to the PLC. Then select play. So the boxes are being loaded onto the entry conveyor. As soon as the pallets reach the loader, because the small loader conveyor motor isn't running, pallets struggle to get onto the loader because of the friction between the pallet and the loader conveyor's rollers. Okay, let's stop FactoryIO. So it would be good to get the pallet to go onto the loader by starting the small loader conveyor as soon as a pallet is detected by the beam sensor. Now let's first go offline and add some ladder logic into network 2 and 3. In network 2 under loading, let's add a normally open contact which turns on M0.0, the loading internal bit, as soon as a pallet is detected by the beam pallet sensor input 0.2. Let's find that in the tag list. There we go. Then select the line and enter in an output coil and address it M0.0, which signifies loading. We can find that in the tag list too by scrolling down. Now, where is it? Ah, there it is. Now let's go down to the output network and take the M0.0 internal bit and use it to start the small loader conveyor. Select the edge and add a branch, then add a normally open contact, and this time we will just type in M0.0, as it's sometimes quicker than searching the tag list. Then enter and select the arrow and add an output coil. Let's have a look at our written list to find the small loader conveyor address, as the text is a little easier to read than the tag list outputs. our Q0.1. Let's hide the list and see the required screen again. Okay, let's enter the address Q0.1 onto the PLC ladder logic code. There we go. Right, now let's download the code to the PLC and accept overwrite the main OB1. Good. No errors, no warnings. And let's start FactoryIO again. This time you can see as the pallet reaches the small loader conveyor and it continues onto the conveyor without any hindrance, you can actually hear the small loader conveyor start up. You might also notice that the small loader conveyor stops just short of the pallet being fully loaded and is pushed the final few centimetres against the backstop. Let's just rewind and look at it again. Just short, and the next pallet pushes it home all the way. Okay, let's stop FactoryIO and add some ladder logic to allow the small loader conveyor to keep running until the pallet is fully loaded and detected by the loaded input sensor, input 0.3. So in the second network, we are going to add another normally open contact to detect input 0.3. And this becomes true when a pallet is right up against the backstops. We also need to change both coil types in network 2 to reset and set. Reset and set. Oops, forgot to address the reset coil. Good, done. Right, let's load the ladder logic into the PLC and start up FactoryIO again and see what happens. So download, again, overwrite. This time we will monitor as well and start up FactoryIO. Here we go. So this time the pallet goes fully onto the loader and then the small loader conveyor also stops because input 0.3, the loaded sensor, has been made true. So now what we need to do is stop the entry conveyor if a pallet is detected by the beam sensor while a pallet is on the loader. So we have to make a change here. So let's stop the PLC, come offline and stop monitoring. We don't actually have to stop the PLC, but I have selected to do so this time. So we add a normally closed contact here so that if a pallet is detected by the beam, it stops the entry conveyor. Problem is, if we leave it like this, no pallets will ever get to the loader. So we have to add another normally open contact to latch the entry conveyor motor on while the small loader conveyor is loading. To do that, we first have to cut the second branch of the ladder logic out by highlighting it and selecting Cut. Then we can add another branch with a normally open contact with the loading internal bit. After that, we can add in another branch and paste the previously cut ladder logic code back into place. So let's download the ladder logic to the PLC. Start the PLC running and monitor the logic. Oops. Now it looks like I went online and offline again. So let's do that again. We are now running and we're in monitoring mode. Let's now see what happens on the entry conveyor when we start FactoryIO. Okay, pallets are going down the entry conveyor. We can see while monitoring the ladder logic, as soon as a pallet is detected, the normally open contact is made to keep the conveyor running while loading is taking place. Then as soon as the pallet is loaded, both the entry conveyor and the small loader conveyor both stop. Great, that's it for now. In the next video, we will see how to transfer high boxes to the right, followed by a further video where we'll amend the logic for the boxes to go in both directions, for left and right. Again, if you like what you've seen and would like to see more, please click the subscribe button and we'll see you in the next video. Thanks for watching and see you shortly.